Hey, what's going on, everybody? Jonathan here, KleinGuy Jon. So doing the unboxing of the Ideal Sure Test Circuit Analyzer. Yes, I'm in the van. So you guys probably saw my video from earlier, my little trip from Staten Island to Brooklyn and into Manhattan. So I'm back here. I promised to do a little. I didn't promise, but I did say I was going to do an unboxing, so let's get started with the Ideal Sure Test Circuit Analyzer model or category number 61-164. Alright, now this baby here, I do have an actual one that I borrowed from a coworker of mine who had this. I have it with me now, but this was just sent to my house because I requested my service department manager to order this one, and along with also the next unboxing, Klein Tools circuit analyzer, their very own, with GFCI and EFCI testing. And so we're gonna unbox this later in the next video. But we're gonna work on this guy, right? So there are some really cool features on this. I've used it. Like I said, my coworker had one. He lent it to me. I think it was awesome. It really, let's see what it says in the back. Actually, it's really helpful. So, Sure Test Circuit Analyzer says true RMS has measures voltage drop under 12, 15, and 20 amp loads. Estimate current load online, which is which abbreviation's ELL, estimated load online, or current load online. Then it also shows you the line voltage, peak voltage, which is pretty good. Frequency, ground impedance, meaning the resistance of the wires, or the ground wire. Hot and neutral conductor impedances. So now it also, when we say hot and neutral, what we mean is the hot is the ungrounded conductor, which is energized, and also the neutral conductor, which is also technically the term for it is system ground, right? Or system ground conductor, is the return back to the source or your meter or the utility, whatever you want to call it. But that's your return. This also shows the resistance of that wire while this tester is energized, which is pretty cool. You don't have to turn off and take out your multimeter and do ohm readings and stuff like that. It actually tells you while it's live. It's pretty dope. Next, it also has a feature of identifies proper wiring in 3-wire receptacles, identifies false bootleg grounds. What it means by bootleg grounds, I've come across one. Sorry, got a little distracted with the driver. I come across an outlet where it was a bootleg ground, meaning they tied a ground wire took a wire, grounded to the ground terminal, and then took the other end and tied it to the neutral terminal of a receptacle or an outlet. When you plug in a regular circuit analyzer, like a circuit analyzer, it'll tell you properly wired and grounded. It's not. If you open it up, when I opened it up, I saw that it was bootleg. That's called a bootleg ground. Okay, it's not very common, but for home inspectors, I'm gonna give a shout out to these home inspectors. You guys do a good job, but be very mindful when it comes to electrical. You plug in your little plug-in tester, and it says, "Oh yeah, it's good." No, open it up and really inspect those devices. You may come across a device that's been bootlegged, meaning, like I said, a ground, because you have you technically have 3 points of your receptacle. You have your hot or ungrounded conductor terminal, your neutral. The hot is the brass, the neutral is the silver terminal or return, which is your return or system ground. And then you have a green screw, that is your grounding terminal, which you bond to the box and so forth. That terminal sometimes will have a wire that's tied in, it's terminated, and then the other end will go into the silver terminal or the neutral. Be very careful. That is a bootleg. It will show up as correct wiring, but be mindful. Take out the receptacle, double check, make sure it's not bootlegged. It's very dangerous because if you have someone plug in a drill or plug in like a reciprocating saw, you will definitely get killed. You definitely get electrocuted. It's not safe. So maybe like on certain equipment, like maybe a lamp or stuff, but if you have a power tool that's encased with metal, you will definitely feel it if it's plugged in. If it's a plug-in power tool, you'll definitely feel it. But anyways, it also verifies dedicated circuits with 61. Oh, it has an adapter with the 61176 adapter. Really? So it verifies dedicated circuits. I didn't know that. Because the one I have, I don't think, well, this might have it. Well, we're going to check and see. Test GFCIs for proper operation. It also includes a carrying case, includes 1 foot extension cord, and it has a 2-year limited warranty. So you have to go see the www.idealindustry or IND.com for warranty details. So let's open it up, man. I want to see that little verifies dedicated circuits. Okay, let's see what that's about. Now, the one that my coworker gave me didn't have any of the instruction manuals. I had to look it up online. Oh, look at this. Look, it has even a plastic protector. Peels off, by the way. See? It has a plastic protector. Peels right off. But I guess that's to keep it clean and, you know, you can still hit the buttons. Now, it doesn't work. This device doesn't work when it's de-energized. You can't turn it on, only when it's plugged in. Ideal Industries, check this out. Ideal Industries Sure Test Circuit Analyzer. It even has the wiring verifications. It tells you if your outlets or some people call them sockets, plug sockets. You can, or just receptacles. You can see that if it's correctly wired or not. If there's an issue. Let's see. So you have the device, right? It has the GFCI test button too. All right. Then you have, of course, this fella, the little cover. You got a bunch of stuff here. You got an estimated load. Oh, look at that. It even tells you what ELL stands for. It has a little paper here, right here. It tells you estimated load online, or ELL measurement. The ideal sure test now estimates the load on a branch circuit to provide an indication of how much capacity in the circuit remains, or to quickly check if the circuit is dedicated. Didn't know that. This function is a rough estimate. No stated accuracy. Okay, so what it's saying is basically it's not accurate. It just gives you a rough estimate. Okay? Like, maybe not, maybe dedicated, but you're going to have to check on your own after that. I know, sounds a little flimsy, but as accurately measuring circuit current has to be done with a clamp meter at the electrical panel. Oh, okay. The proprietary way in which these calculations are made allows to the user to plug the unit into an outlet and quickly determine the current load on that branch circuit. Both the distance of the sure test from the load and branch circuit impedance will affect the accuracy. Best accuracy is obtained by positioning the sure test in the same outlet as the largest load on line. Otherwise, try to position the sure test between the load or loads and the electrical panel. The maximum amperage reported by the tester is 15 amps. Okay. Then you have your warranty registration right here, right? And a certificate of conformance. And it even has the information too with serial number. Pretty dope. Sorry, just gotta see. Can't really show the serial number because I'm making sure that it stays within this device. Ideal Industries Incorporated hereby certifies that this product was checked and or calibrated in accordance with applicable calibration practices using equipment that is calibrated to standards traceable to the National Institute for Standards and Technology, or NIST. these procedures are ISO-9001 controlled, or 901 controlled, and are designed to assure that the instrument meets its published specifications. This meter is warranted to the original purchaser against defects in the material or workmanship for the period stated in the instruction manual, excepting normal wear and abuse. So in other words, wear and tear is not going to warranty it. It has to be, make sure that it's not a manufacturing fault or an issue. Basically, the manufacturer gives you a defective device. That means you got a warranty. It's liable. It's acceptable for warranty. So you got your instructions manual, and you have a quick reference sheet, which is pretty cool. So this is the instruction manual right here, and then you have a quick reference sheet, which is pretty dope. It's good to have something like that around, right? Got front and back. So this says, you see now, I was just explaining earlier in a video that I was doing about AFCIs, and I was talking about this test, and they have one like this that does both GFCI and AFCI, and look, they even have a drawing of it. It has the additional AFCI button. It's hard to find that because I saw it only one time, and then that was it. That baby got sold quick on Amazon, and whoever's got it, man, you're lucky, because it is pretty expensive than this one. So you got a quick reference sheet. It's for the shirt test 164 and the 165. This is the category number. I know it's probably backwards or something, but it says 61-164. So the 164 does GFCI testing, which is this model, and then the 165 does GFCI and AFCI testing, which I was trying to look for and I couldn't find, so I had to get the Klein one. Test number 1, wiring configuration, verifies the outlet is properly wired to the hot, neutral, and ground conductors. False bootleg. Ground indicates that the neutral and ground conductors are unsafely bonded together at the outlet or within 15 feet of the shirt test. Hence, the shirt test will indicate a false ground within 15 feet of the panel, where the only good neutral ground bond should exist in the circuit. With a bootleg ground, if the neutral is compromised, then so is the ground conductor, posing an electrical shock hazard. Okay, that's what I meant by bootleg ground, or bootleg, grounded device. Then you have test 2, line voltage. Then you have test 3, voltage drop. So basically this simulates, basically when it does the voltage drop test, it'll tell you 3 indications of simulated voltage drop. Let's see here. You have, so a 15 amp load is applied and the voltage is measured. The voltage is compared to the original voltage from test number 1 to determine the amount of voltage drop. For example, let's say the line voltage in test 1 was 120 volts. After applying the 15 amp load, the loaded voltage, or VL, drops to 108 volts. That's a 12 volt drop in voltage, or 10%. So basically, it'll tell you on the screen here, when you switch with using these arrows, when you scroll down at first, when it's first energized, it'll tell you the voltage drop. It'll simulate a test. It'll put in a load on that circuit to tell you, hey, well, 15 amps. Let's see how this branch circuit could handle 15 amp load and see what the voltage drop is. It'll simulate that and it'll tell you the voltage drop, and then on the top of the screen it'll show you the voltage, the actual voltage, and it'll tell you the big bold numbers, the percentage of the voltage drop, and then underneath it'll tell you the amperage. So when you go down to voltage drop option, when this is plugged in, you scroll to the side, the little side arrow, to simulate 15, 20, and 12 amp voltage drop simulation. So yeah, that's pretty cool. I like it. I like it a lot. Alright, NEC recommends the National Electrical Code, or the NEC, recommends no more than 5% voltage drop. If greater than 5%, higher resistance exists somewhere in the circuit, which leads to heat, which could eventually lead to glowing connections, meaning they'll turn cherry red. Yeah, that's bad. And then to possibly a fire. And for power reliability to equipment, the voltage under load, or VL, should be more than 108 volts. And then you have test number 4, available short circuit current, which is abbreviated ASCC, calculates the max amperage from a bolted fault condition. If all three conductors were to be dead shorted together, amps value needs to be less than the maximum protection provided by the breaker rating, typically 10 kiloamps. 10 kiloamps represents 10,000 amps, so 10,000 kiloamps. The kilo represents 1,000. Just so some of you guys get a little lost. It also does GFCI testing only for the 164 model, and the test number 7 is the AFCI test for model number 61-165, which is pretty awesome because it'll tell you the amount of time where it trips at, because GFCIs and AFCIs are different. GFCI meaning ground fault circuit interrupter, and AFCI arc fault circuit interrupter. They test differently, and there are different milliamps for them to trip. For GFCI to trip is between 4 to 6 milliamps for the GFCI to trip, and for a AFCI it's 30 milliamps. Okay, for it to trip. All right, so those are the standards for those devices. Those are the minimums or the maximums, or whatever you want to say. But yeah, this is pretty cool. I'm going to keep this around with me. What else we got? And we got the case for it. So open it up. There's some test equipment in here, I guess. Let's see. Oh, you got the plug. Well, yep, you sure got the plug. So this is the power extension cord that it comes with. Now, it's a 12-inch 1-foot cord wrapped up. All right, pretty cool. Now, I do have a similar cord in the back that's at least probably more than 12 feet. It stretches out a little bit, but they say the shorter your wire, especially if you have a ground, the better. And for this test, at this length, for a 12-inch length, I think it gives a much more accurate reading. If it was longer, it'd kind of be like, you're adding on more resistance and you're kind of not getting an accurate measurement. So that's the reason why they give you a short cord to plug into the device. So how you connect this to the device? Well, simple. You got the plug into an outlet, GFCI or AFCI outlet, and then you have the other end, female end, because you have a male right here at the top of the device. You just plug it in, line them up. And then once you plug this in, this will energize. Once you put into an existing receptacle with live power, with current or voltage, this will energize and it'll give you a reading. So, thanks to my service manager for this. I'm gonna give him a shout out, Gabir. Thanks a lot, man. This will really help me out, and I will have to give the other one back to my boy Max, my coworker. Now, unfortunately, this does not have the allocators because my coworker, one of the guys I worked with, he lent me his, and he had a purchase. I believe he had a purchase, or it came with the alligator clips, which is pretty cool. This does not have it, so you might have to buy it separately, purchase it separately. The alligator clips they're huge, they're well insulated, so you don't have to worry about getting shocked or getting hurt, and I'll show you that right now. I think I have it with me. So let's put this bad boy back in place. We can take this cover off because it's eventually going to peel off anyway. There's no point of having it, so I'd love to keep it, but it's going to eventually peel off and get damaged. It doesn't really matter at this point. So basically, you tuck this baby in, and then we put this in, I gotta mark it as, put it under the company name because it's purchased by the company, not by me. Unfortunately, guys, sorry. I know it sucks, but let's see. I think I have. Let's see. Oh, I think this is it right here. So, all right. So this is the other one my coworker lent me. This is his. He hardly ever used it, but as you can see, obviously this is the same tester. You know, both, and I'm gonna prove to you this is the same. This is the same tester because my coworkers versus mine. The one I'm using, here it is. This is the new one. This is currently the one I've been using for my coworker. It's still in great condition, feels brand new. So here's the other part, the other accessory. So for the alligator clips, you see these are pushed in. You see these are what the alligator clips look like. You just push them in according to the color code, and it's pretty dope. I mean, I would assume that not only do you get the alligator clips, because these are like, you can just connect them. This is the ground, you connect them. I think you can also get test leads on these, like the probes. And look, it connects the same way. You connect it the same way onto the tester, boom, and then you just connect it to live wires, bare live wires. If you don't have a ground wire, you can always take the ground in and bond it, clamp it onto the metal frame of the device box or electrical box and stuff that the device is hooked up to. So yeah, and you'll still get a good reading. You'll still get a reading of the ground. You can even, it'll still tell you if the system is grounded and bonded to the equipment, and if it doesn't, then you'll have to find out why that is. You'll have to go check the service equipment down either in the basement or wherever it may be, and make sure everything is bonded mechanically, electrically and mechanically. You want everything to be connected that way, electrically connected. So but yeah, this accessory you have to purchase separately. So I'm gonna assume he bought this separately, but it does work with this device, and it's pretty cool, man. I love it. It does fit in the pouch, but you'll have to take off the alligator clips. If you put them in, it's not going to fit. It's going to be a little overcrowded. So you got to shove it in there a little bit to get it in. It comes with a small little pouch here on the side, and then you can just stick the other. I put the ground alligator clip in this little pocket, and then I just put the rest on the sides of the pouch as best I can. And hopefully it should zip up. It has two zippers, which is great. Yeah, it zips up all the way around. Put the other end, and there you go. Boom. Fits beautifully. I'm going to keep this actually with me. And yeah, that's basically it. I mean, I could also try and you can even make your own alligator clips. This is pretty cool because this is what I did. I used this for my circuit tracer, for my Klein circuit tracer finder. You can get an original drop cord, from like a supply house or Home Depot, and get some alligator. They sell alligator clips in Home Depot too. You just get some of those and you just start. Yeah. Now I know it's black on a green. I couldn't find a green one. This is all they had, the black and the red. So I tie those up. Red is supposed to be on the black and the black on the white. It is what it is. Yeah, and you can just make your own. Get some crimpers, crimp it down, and you're good to go. All right, and you just plug in tester. I have another cord that's similar to the power cord for this for the circuit analyzer in the back. I can always just unplug that and make alligator clips out of it, since now I have that guy right there, and I can just cut it short, put alligator clips on it. Boom, you're ready to rock and roll. So be very resourceful. If you're an electrician, be resourceful. You don't have to spend a lot of money on this. I think this goes for $3, and the alligator clips for $2 or maybe another additional. So you're spending $6 on this, and online I think these go for $15 with everything else. So you might as well just spend $6, maybe less, and make your own, because it's totally worth it. I lost the one for my digital circuit finder. I lost the original one. that I brought separately. That was like $15, almost $16. And I decided, you know what, screw it, I'll make my own. I still have the other plugs and stuff, and I'll just make my own. It works the same way. It's nothing different. But in any case, guys, that's it for the circuit analyzer. I hope you enjoyed watching this. If you guys have your own, let me know. This baby is useful. Let me know in the comments section how you use it. If you're a electrical contractor, and this has saved you time and money, ring it in the comment section down below. Until next time, guys, thanks for watching. I'll see you on the next one.